So I wanted to introduce this concept of customized repetitive manufacturing. We have all of these acronyms we bandy about: CAD design, um, which is computer aided design. We have computer aided manufacturing, and in the architectural world nowadays, we're starting to kind of introduce this new concept, which is customized repetitive manufacturing. And which obviously doesn't seem to have much weight to it until you see how it's played out in the actual manufacturing environment as it relates to architecture. So with that acronym in mind, um, this is a link to the paper that really kind of, I think for the first time I'm seeing it, introduces the subject. But it really brings up this idea of the way manufacturing environments work to create our architectural projects for us today. And these are, I'll come back to that video. These are all hyperlinked, so they all have interesting um, aspects to them if you open up the slides and click through to the links. This is a manufacturing of a custom panel. We'll come back and just take a look at that. The idea, though, of this custom repetitive manufacturing is that we're using, in many applications now, we're creating these facades that have really all identical styles of individual componentry, but no two are alike because they are changing in dimensions as they move across the span of the facade. And something I've experimented with also, and kind of to introduce even to myself that concept. Here I've got a folded frame system extended out over a facade, and this was work at Rigidized Metals, where we would laser cut a panel with perforations in it, and then that panel could be custom folded. Very complex to actually fold and fabricate these types of panels, but facilitated by this idea of perforating. So you could literally bend it with your hand in order to create the shape. But each one of these elements, and that's kind of an idea of a completed assembly, but each one of these elements is unique. Each one of these has something different. As you'll notice, there's 3 here and there's 3 here, but we're extending out over a much larger range. So there's virtually no commonality in the parts. As a matter of fact, there's no guarantee of commonality. There's no telling which way, whether this is a linear function in the spacing between here and here to from here up to here. So the implication here is that it's every part is different. And here's 3 different parts laid out to give you an example of that. And one of the ideas of experimenting through this is there's plenty of, once you see this idea of these, unitized cells, you can also see all kinds of ways to vary and change and enhance their visual appearance. And then I wanted to take you back to this idea of this panel forming. As I said, each panel is different, and that makes for very complex manipulations of making things. And in this case, this is a machine now where a blank panel is set in, it's been laser cut. And all of the bending operations then happen in an automated fashion. And it's quite fascinating. And this is obviously to make an electronic computer panel or some other kind of a framework. But you can see the precision with which these tools can now create and form and shape elements. And just to have a fundamental understanding about this, when you think about making panels, how they could be bent, how they could be automated in their handling and manufacture. And each one can be unique because each one is being manipulated and formed individually, not as a group as you might think of if you were stamping out parts. So that's enough of just this visualization of this, I think. And we'll pick up on the next series in the next video clip.